Okay, so we're going to take a look at determining what data values are outliers in a data set. So when we take a look at Derek Jeter's hits per season here, and we can see right off the bat we have these two 12s that seem to be outliers. They're different. They're far apart from the rest of the data set. Well, let's go ahead and determine mathematically if they actually are outliers. To do that, the first thing we're going to have to do is we're going to have to find the IQR. To find the IQR, we have to find the median. And then once we know the median, we can find the two quartiles, subtract our quartiles, and find the IQR. We've got 20 data values here. An easy way to determine the median of a data set is to use this little n+1 divided by 2 rule. If you take the number of data values, add 1 and divide by 2, it tells you where to find the median. Other people do this whole counting in from the ends thing and all that stuff. Those are all fine methods as well, but this n+1 over 2 works pretty well. So in this case, we're going to have 21 over 2, which is 10.5. Now, don't jump the gun. The median is not 10.5. This is just telling us that the median is between the 10th and the 11th value. Well, our data cells here, our cells are starting at 2, so the 10th value is actually number 11. So our median is going to be found between the 11th and the 11th and the 12th. Well, it's actually the 10th and the 11th data value, but cell 11 and cell 12. So halfway between 190 and 191. So the median in this case is going to be 190 and 1/2. We actually don't necessarily need the median. We just had to know where it lies so that I could divide the data set into two halves, an upper half and a lower half. Well, let's take a look at the lower half now. If we look at the lower half, we want to find the median of that lower half of the data so we can find the first quartile. Well, there are 10 values. Again, 10 plus 1 is 11, divided by 2 is 5.5. So the median of the lower half of the data is between the 5th and the 6th value. Well, if we count down through here, 1, 2, 3, 4, 5, and 6, it's going to be between 162 and 179. Well, if we average 179 and 162, we get 170.5. And that is going to be our Q1. Let's do the same thing on the upper half of the data. Again, it's going to be between the 5th and the 6th value. So 1, 2, 3, 4, 5, between 203 and 206. So our Q3 is going to be halfway between those two. And if I can do the math correctly in my head, that's going to be 204.5. 204.5 is our Q3. At this point, we can go ahead and find the IQR. The IQR is going to be 204.3, 204.5 minus 170.5. And we could use Excel to do these calculations for us. I happen to have a calculator right in front of me. I'm just going to do that quickly. And the IQR is 34. Now, we have to find something called the upper fence and the lower fence. The upper fence is the cutoff from what separates just regular old data values and actual outliers. The upper fence is calculated by taking the third quartile plus 1.5 times the IQR. So if we take the IQR, multiply by 1.5, add that to Q3, that'll tell us anything beyond that value is going to be an outlier. Well, Q3 was 204.5 plus 1.5 times the IQR, which we just calculated, and that was 34. So in this case, the upper fence is going to be, do a quick calculation here, 255.5. So any data value higher than 255.5 would be an outlier. Well, you can see clearly we don't have any of those. Our highest data value is 219. So we have no high outliers. let's calculate the lower fence. Same process, but this time we're going to take Q1 minus 1.5 times the IQR. Q1 is 170.5 minus 1.5 times 34. I think, yeah, 34. So here we go, 170.5 minus 1.5 times 34. So the lower fence is 119.5. Well, let's take a look at our data set. If we look closely at our data set, we can see we've got a 149. That's within the fences, so that's not an outlier, but these two 12s are in fact outliers. They are lower than the lower fence. So in this case, we have 2 low outliers and no high outliers. And that's how you determine mathematically if a value is an outlier.